Projection of planes. Projection of planes. Okay, what is projection of planes? Before going to that, just recall what we learned in the last classes. The first orthographic projection we see projection of point, that is zero dimensional. Next one is projection of line, that is one dimensional. Now we come to projection of planes. Projection of planes is two dimensional. Okay. Now how we can draw the orthographic projections for two dimensional objects, that is nothing but projection of planes. Okay. Now in the planes, what are the different cases we can come across? First one is the plane parallel to either HP or VP, either HP or VP, and perpendicular to other plane. Perpendicular to other plane. Plane parallel to either HP or VP and perpendicular to other plane. That is the case one. The second one is plane perpendicular to either HP or VP and inclined with HP or VP. This is the second case. The third case is plane inclined to both the HP and VP. Inclined to both HP and VP. Now you can see, first one is plane is parallel to HP or VP and perpendicular to other plane. The second one is plane inclined with either HP or VP and perpendicular to other plane. Next, third one, plane inclined to both HP and VP. Okay, HP or VP. Right. Now, in these three cases, one by one, we will see. And here we need to remember, when a plane is parallel to HP, in the top view, we can see its true length and true dimensions of the respective plane. And if the plane is parallel to vertical plane, then in the front view we will see their true dimensions. Now I will take one plane and I will explain. This is the hexagonal plane. Okay. Suppose this hexagonal plane is parallel to HP. In the top view, we can see its true dimensions, true angle of inclinations. So that we need to draw top view first in this case. Suppose the plane is parallel to VP. In the front view, we can see their true dimensions and true inclinations. Therefore, we need to draw front view first. Okay. Suppose the plane is parallel to VP, and for this, top view obviously it is a line which is parallel to reference line. Now see, then the plane is like this, parallel to HP and perpendicular to VP. In the top view, true dimensions, true angle of inclinations we can see. In the front view, a line we can see which is parallel to reference line. Okay, these things we need to remember while doing problems in the planes, right? Now, for the first case. For the first case, we will consider the problem. A pentagonal plane of 30 mm side, a pentagonal plane of 30 mm side is given in the problem as 30 mm side is parallel to horizontal plane and perpendicular to VP. Right. One of its side is parallel to VP. The plane above HP 20 mm. Draw the projections. Now, first imagine the position of plane by observing the data. This is the pentagonal plane, and here it is above, parallel to HP, perpendicular to VP. This is the position. And one more condition it is given. One side is parallel to VP. In this position, when the plane is parallel to HP and perpendicular to VP, in this position we can consider plane like this in any position. But another condition is one side is parallel to VP. That means this is the fixed position. Okay, this we need to imagine, and the distance in between HP and the plane, that is 20 mm. Okay, now we need to draw the top view first, because true dimensions are visible in the top view. After that, if you rotate the horizontal plane, the top view will be like this, right? In this position only we need to draw the top view. Right, now we will draw. With 30 mm side, this is the XY reference line with 30 mm side. Okay, this distance we can consider any distance, because it is not given in the problem. Okay, in front of VP, how much distance? It is not given. That is the reason any distance. Right. Now, construct pentagon by considering included angle as 108, and this is a regular pentagon. Students don't draw just a simple pentagon, but by considering dimensions, included angle as 108, we need to draw the pentagon. This is 30 mm, and the included angle is 108 degrees. 108 degrees, right? Now, the required top view, that is over. Now come to the front view. The plane is above HP 20 mm. If it is above HP, that distance is true distance is clearly visible in the front view. Therefore, draw a line at 20 mm from the reference line. After that, project the plane from the top view. Here we need to give the notation, let it be A, B, C, D and E. Okay, for the front view, this is A dash, E dash, D dash, B dash and C dash. Okay, now the required portion of the projection that we need to darken. Okay, and you need to give the dimension as this is equal to 20 mm. This is equal to 20 mm, right? This is the given solution. This is the solution we required. Here now we will consider an hexagonal plane. A hexagonal plane, note down, a hexagonal plane of side 25 mm, perpendicular to HP, perpendicular to HP. In front of VP, 30 mm. In front of VP, 30 mm. Hexagonal plane is given in the problem, and side equal to 25 mm. Okay, 25 mm side hexagonal plane is perpendicular to HP and in front of VP. Okay, 30 mm. Next one, the center point of the plane, above vertical plane, in front of horizontal plane, the center point of the plane, above HP, 60 mm, in front of VP, 30 mm. The plane is parallel to VP. Now we will analyze the data and we will try to understand the data given and orientation of the object. Now a hexagonal plane is given. Okay, this is the hexagonal plane. At this point here, this plane is perpendicular to HP and in front of VP. The plane is perpendicular to HP in front of VP. And another thing, parallel to VP also. This is the position. Hexagonal plane side is given, center position also given, right? In this condition, the plane has a number of orientations. Another condition it need to specify. Note down that condition. That condition is one of the side of the hexagonal plane inclined with HP 45 degrees. Okay, now we need to draw the respective position. When it is inclined with HP 45 degrees, first draw the reference line. Next, a 45 degrees line. This is a 45 degrees line. Okay, one side of the plane is inclined with the HP 45 degrees. And another thing is, the center of the hexagonal plane is above HP 60 mm. Okay, these two conditions we need to satisfy, right? Now, instead of drawing a reference line or darken the reference line first, draw 45 degrees line with the horizontal line. Horizontal line, we need to draw 45 degrees line first. After that, draw a line of length equal to 25 mm and construct hexagonal plane here, right? This is, let it be A, B, C, D, E and F. Okay, and this is the front view. Therefore, we need to use A dash, B dash, C dash, D dash, E dash, F dash. Right. Now, locate the center. To locate the center, opposite sides you need to connect. There is opposite sides you need to connect. You got the center. Okay. This center above HP 60 mm. Therefore, after finishing up this hexagon, you need to measure a 60 mm. And at the distance of 60 mm, you need to draw the reference line. Okay, here the reference already what I drawn, it is at a distance of 60 mm. I consider like that. Okay, in the drawing sheet, after drawing this hexagonal plane from the center O, we need to draw a reference line at a distance of 60 mm. Right, this is 60. Right. Now, come to the top view. When it is parallel to VP, the top view is parallel to reference line. Okay, how much distance we need to consider? In front of VP, whatever be the distance the plane possessed, that distance we need to consider in the top view. Now, in front of VP 30 mm. Therefore, from here we need to consider a distance of 30 mm and draw a line. Okay. Now, on this line only the top view is obtained and that view is parallel to reference line. Now, project it downwards. Okay, perfect projection that is required. Okay, if I consider 45, the lines will be like this. That is the reason just I adjusted, right? Now, we need to darken the required portion. This is the required one. And this is A dash. This is B dash, C dash, sorry, A, B, C. Next, this is D. This one is E. E will come out and F will be inside. E projection this will be like this. Yeah, is like this, right? This is the projection and this is the required top view. Okay? Plane inclined to either HP or VP and perpendicular to other plane. That problems we will consider now. Plane inclined to either HP or VP and perpendicular to other plane. Okay. Now take one problem. A pentagonal plane, one of the side in the horizontal plane and perpendicular to VP. A pentagonal plane, one of the side is in the horizontal plane and perpendicular to VP. The plane having 25 mm side and it makes an angle of 30 degrees with the HP, and it makes an angle of 30 degrees with the HP. Draw the orthographic projections. Right? Now observe the given data. The given surface is plane, pentagonal plane. Therefore, pentagonal plane. What is the side? Side equal to 25 mm. And one side of the plane lies in the HP and it is perpendicular to VP. Pentagonal plane side is given. This is the geometric parameter, and this parameter gives us its position. The one of the side of the plane lies in the HP perpendicular to VP. Next, that plane makes an angle of 30 degrees with the HP. Right. Now we will imagine the respective position. See, this is the pentagonal plane. This pentagonal plane, one side, suppose if you consider this is the horizontal plane, one side is in the HP. And this side, it may be like this, it may be like this, okay? Several orientations are possible, okay? But this side is perpendicular to VP. Therefore, this is only the orientation. At the same time, the entire plane makes an angle of 30 degrees with HP. In this orientation, we need to draw. Right. Now, the students just think, in which view we can see its original or true dimensions. In the top view, if you see, if you project like this, all projected lengths are visible except this line. Okay. Now in the front view, it is perpendicular to VP, then it is a inclined line, inclined straight line. Now in this case, we need to assume two stages. One is simple position and the second one is first stage projection. Okay, here the plane inclination is given. The plane is inclined with HP 30 degrees. Therefore, we need to assume that the plane lies in the HP. Okay, when it lies in the HP, in the top view we can see its true dimensions. Right? After that, if you rotate the horizontal plane, the top view will be like this. That means this side perpendicular to reference line. Okay, therefore in this position only we need to draw the respective pentagonal plane. Now we will draw. See, draw the reference line XY, and this is the position, and side we need to consider 25 mm. I will draw line directly. Okay, with side 25 mm you need to draw. Already how to draw pentagon, you know. Okay, this is a pentagon, regular pentagon, and each side is 25 mm, included angle is 108. This is A, B, C, D and E. Just I will darken the respective pentagon. Right. Now we go for the top view. Suppose if it is parallel to HP, the top view, front view will be above the reference line, but it lies in the HP. When it lies in the horizontal plane, in the front view will be coincides with the reference line. Now project it upwards. Right. And the required one, this is A dash, this is B dash, C dash and E dash. Next it is D dash. And here, this one is required one. Okay. Now, when the plane is like this, without disturbing this end, if it is moving like this, the length of the front view, it will not change, but whatever be the true angle with the HP, that is visible. True angle of inclination with HP 30 degrees. This is 30 degrees line. On this line, here A1 dash and B1 dash. This side is in the HP, therefore its projection front view coincides with the reference line. Next, this is C and this is D. Okay, this one is the required front view. C1 dash, E1 dash, D1 dash. Now, for the final top view, we need to project it downwards. Because top view, if you see like this, these are the projections. We project it downwards. Now see, this is the plane, and if you move like this, by considering inclination, this is the horizontal plane and this is inclining. Okay, inclination with HP, when we rotate the HP, this will be like this. When we move like this, the position of E, okay, it will shift like this, right? Position of D, position of C, also those are lies in the horizontal line only, right? Now, that is the reason, draw horizontal lines. Okay, now locate the respective positions. This is the position of A1, this is B1, this is C1, this is D1, this is E1. Okay, now AB, BC, CD, DE and AE. Okay, this is the required top view, required front view, right? A rectangle of 25 by 50, that means 25 mm width, 50 mm length. A rectangle 25 by 50 looks like a square in the front view. Looks like a square in the front view. One side of the rectangle lies in the vertical plane. One side of the rectangle lies in the vertical plane and the entire plane is perpendicular to HP. Draw the projections and find the inclination with VP. Okay. Now we will observe the data and we will analyze the respective position. Now, the given plane is a rectangle. This is plane is rectangle. And dimensions 25 mm width and 50 mm length. Okay. And it looks like a square in the front view. Front view is square. Square dimensions also not given in the problem. You can guess the dimensions are 25 by 25. Okay, 25 by 25. Right. Now, the plane, one side is in the VP, one side in the VP. Okay. Next, the plane is perpendicular to HP. This condition given. Asked to find what is the angle of inclination. Angle of inclination with the V. Like this. That means one side is in the VP and the entire plane is perpendicular to HP. It makes some angle. That angle we need to calculate. Okay, at one angle of inclination, the front view of this rectangle looks like a square. Okay, therefore this is the orientation, right? Now for the front for simple position, which view we need to draw first? Here the plane inclination is there, therefore we need to consider this plane lies in the VP for the simple position. If it is lies in the VP, we need to draw front view first. Now this is XY reference line, and by taking 25 mm and length equal to 50 mm, we need to construct a rectangle. Okay, this is A dash, B dash, C dash, D dash. This is the simple position front view. Okay. Now project it downwards. If you project it downwards, the top view, only this line we can see. Okay. Therefore, this is the front view. Okay. To distinguish this line, I want to darken. Okay. I increase the line thickness. Right. This is A, D. This is B, C. Okay. Now it is inclined with the VP, some angle of inclination, we don't know, but the front view is a square. Okay. Therefore, if you project this, because after the inclination with VP, the C will shifts here, D shifts here, okay, due to inclination, and that is the reason we draw the respective projections, horizontal projections. And this is 25, and by considering this 25, we need to draw a square. Now, this is the square which we can visualize in the front view as given in the problem. Right. Now this is A1 dash, B1 dash, C1 dash, D1 dash. Okay. Now project it downwards. And we can see inclination with VP in the top view very clearly. Now this AB, AD, it is in the VP, then its projection here only. This is A, comma, D, A1, D1. A1, D1. Right. With this length, that means 50 mm length, you need to draw an arc AD as center. And this line represents the required top view. Okay, this line, okay, if it is moving like this line, okay, then the angle with the vertical plane, okay, that phi, we need to measure it and we need to write perfectly because it is asked in the problem. Here we consider rectangle. This similar problem in the examination they may ask, an ellipse looks like a circle. An ellipse looks like a circle. Ellipse minor axis length, major axis length, that will given in the problem. And the one end of the major axis in the VP and entire plane makes an angle phi with VP. Draw the projections and find the angle of inclination. Okay, that likewise circle looks like an ellipse, and ellipse looks like a circle. Okay, circle looks like an ellipse. Okay, likewise problem will give, or a ellipse looks like a circle. That problem is given, and here also a square looks like a rectangle. That may ask. Okay, similarly, an isosceles triangle looks like an equilateral triangle. Okay, then what will be the angle of inclination with VP? Likewise, this type of problems may ask in the examination. Right. Now we will go for the next problem. Draw the projections of a circle of 50 mm diameter, a circle of 50 mm diameter having its plane vertical and inclined at 30 degrees to VP. Plane is vertical, that means perpendicular to HP, inclined at 30 degrees to VP. Its center is 30 centimeters above HP and 20 centimeters in front of VP. Plane is circle, given plane is circle, and its diameter 50 mm. Right. This plane is inclined with VP 30 degrees. Plane inclination with VP 30 degrees. Right. And position of the center that is given. Right. That means 20 centimeters in front of VP, 30 centimeters above HP. Okay. Now the plane like this. It is inclined, and this is 30 plane inclination with VP 30 degrees, and position of the center. Position of the center is 30 centimeters above HP. Above HP 30 centimeters. And 20 centimeters in front of VP. Here we need to convert this in, we need to take in mm, because on drawing sheet mm is the better measurement for accommodate the entire drawing. Right. Now the plane is inclined with VP 30 degrees. When it is inclined, we cannot visualize two dimensions. Therefore, we need to assume that it is parallel to VP like this. Therefore, we can see two dimensions in the front view. Therefore, we need to draw a reference line first, XY. And the center is above, HP 20 mm. 30 mm above HP. Therefore, above HP 30 mm, we need to draw a line. Right, at 30 mm, and let it be O. And with 25 mm radius, draw a circle. With 25 mm radius, draw a circle, and the circle doesn't have well-defined edges. Therefore, we need to divide this circle into number of equal divisions. Let it be 12. By taking 30 degrees, we can divide this circle into 12 equal divisions. Okay, right. Next, what will be the top view? It is in front of VP 20 mm. Therefore, at a distance of 20 mm, we need to draw another line. Okay, that means we locate the position of fixed point first. After that, we go for the front and the top views. Right. Now project the front view.